Hello everyone, our next question is a parallel plate capacitor of area 50 centimeter square. So again they are given on a parallel plate capacitor, that capacitor having that area of 50 centimeter and the plate separation is 3 mm. Okay, is charged initially at 80 microcoulomb, right? So due to radioactive source, the medium between the plates gets slightly conducting and the plate loses charge initially at the rate of 1.5 into 10 to the power of minus 8 coulomb second minus 1. So they ask what is the magnitude and direction of displacement current and what is the magnetic field between the plates. So they give the data given in the question is area and the charge, how much the separation between the plates and how much charge initially get that parallel plate capacitor and the rate of change of charge. Okay, so these are the data given in that question. So now we'll go for that answer. So you know the formula for displacement current, so that is ID is equal to epsilon naught into d pi e by dt. So pi e nothing but electric flux, so that is E into A, so area into electric field. So once you substituted here pi e is equal to E into A, so we need write that value in pi e, so epsilon naught into E and then dE by dt, right? So next step is epsilon naught into A and d by dt. Here E is the electric field, so that electric field of parallel plate capacitor formula is Q divided by epsilon naught into A. Okay, so we already discussed these terms. So epsilon naught into A, from that Q by epsilon naught into A, 1 by epsilon naught into A is come out from that value, equation. So then the balance term is a d by dt and already we have a Q, so dq by dt. So here dq by dt is the rate of change of charge. So the rate of change of charge is given in that question. So that is ID, that is equal to dq by dt, that is equal to 1.5 into 10 to the power of minus 8 coulomb second minus 1, right? So here epsilon naught into A, epsilon naught into A, so both are cancelled together because both are divided together. So here multiplied, he said divided, so both are cancelled. So balance term is dq by dt. So dq by dt is nothing but rate of change of charge. So already they given. So ID is equal to dq by dt, that is equal to 1.5 into 10 to the power of minus 8 coulomb second minus 1. So that's a magnitude. Okay, and then they are asking what is the direction. So now we find out that what is the magnitude of displacement current. Now we'll go for the direction. So the direction of displacement current is opposite to that of electric field E, right? So once the direction of displacement current is opposite to the electric field means that conduction current also opposite, right? So hence the opposite to that conduction current, so the net current between the plate is 0. Okay, displacement current is opposite to that electric field, so that's why we are saying that hence opposite to the conduction current, so the net current between the plate is 0. And then we are using Ampere Circular Law for finding the magnetic field between the plates. Okay, first we find out that magnitude and direction of the displacement current, and then next they are asking what is the value of magnetic field between the plates. For that we are using Ampere Circular Law. So with ID, that is replaced by ID, that is equal to IC plus ID. So here I is a current, so here IC is equal to conduction current, D is a displacement current. So both are opposite direction, so it becomes 0. So the Ampere Circular Law, so close integral of B vector into dl, so that is equal to mu naught into I. Here I is replaced as IC plus ID. So IC plus ID value is 0, so the total value is 0, so that the magnetic field within the plates is 0 at all points. That's it. Hope you understand. Thank you so much for watching.